We have a circuit with multiple resistors and a single EMF source as shown in the picture. The power dissipated in the entire circuit is given. The EMF voltage is given, and one of the resistors is unknown, and we'd like to find that resistance. So let's start by calculating the equivalent resistance of the circuit given the power and the EMF voltage. Power is equal to EMF voltage squared divided by R equivalent. Rearranging my equation, I get R equivalent equals EMF voltage squared divided by power. Let's calculate this numerically. We get R equivalent equal to 4.8 ohms. Now, let's notice that the group of resistors R1, R2, R3, that group is connected in series with resistor R4. So I'm going to subtract R4 from the equivalent resistance to find the equivalent resistance of the group at the top, which is R1, R2, R3. So here's the idea. I label the equivalent resistance of the group of three resistors 1, 2, 3 as R sub 1, 2, 3, and that plus R4 is equal to the equivalent resistance that we just calculated. So we're going backward. First, we're going to find R1, 2, 3 by subtracting R4. We get R1, 2, 3 equal to 2.8 ohm. Now let's focus on the group R1, R2, R3. R1 and R2 are connected in series, and the two together are connected in parallel with R3. Let's set up our equation for that. Now I'm using the parallel connection formula with reciprocals. So 1 over R1, 2, 3 is equal to 1 over R3 plus 1 over R1 plus R2. So R1 plus R2 is the equivalent resistance of this group right here. So this is going to be R1 plus R2, and then it's connected with R3 in parallel, hence the use of the reciprocal formula for the parallel connection. Here I have isolated R3. Let's substitute the numerical values and calculate. We get R3 equals 3 ohms.